Hello everybody, today we are going to do Euler's theorem. Basically Euler's theorem is done for homogeneous functions. So let us understand what are homogeneous functions. A function f of xy is said to be homogeneous of degree n if we can represent the function f of tx ty is equals to t to the power n f of x y where t is greater than 0 for every positive value t. So let us understand the definition with an example. For example, tan inverse y by x. So here we see if we represent, if this is f of x y, so let's say f of tx ty is equals to tan inverse ty by tx, which is equals to t to the power of 0 f of xy. So here we see that this is an homogeneous equation, homogeneous function of 0 degree. So now another one, x square plus 4xy. If this is f of xy, then f of tx ty is equals to tx whole square plus 4tx ty. Here we can see that t square is common, x square plus 4xy, which is t square f of xy. Hence this is homogeneous function of order 2. This is the order. Alternatively, we can define it as a function f of xy is said to be homogeneous of degree n if f of xy is equals to x to the power n f of 1 comma y by x. Here we put tx is equals to y 1. Or sorry, this is x power n 5 or x to the power n 5 y by x. So this is alternative function. So we now define Euler's theorem. So let us understand what the theorem says. If u, which is a function of f x and y, be a homogeneous function of two independent variables x, y of degree n, then x del u by del x plus y del u by del y is equals to nu. We assume that u is differentiable, or equivalently we may assume that u possesses all the continuous partial derivatives. So we assume that all the partial derivatives, that is du by dx, du by dy, all exists. So we now try to prove the theorem. So what the theorem says? The theorem says if u, which is f of xy, is homogeneous. If this is homogeneous, then x del u by del x plus y del u by del y is equals to nu. So this is the relation that Euler's theorem gives. So for this, so let us understand what we have. So we have that u, which is f of xy, is homogeneous. So if this is homogeneous, then it will follow this convention. So u may be represented as some x power n phi of y by x. Since this is homogeneous, so it will follow x to the power n y by x. So now let us find del u by del x. Let us see what it is. So del u by del x is equals to, so let's see, so this is with respect to x. So this is a function of x, and here we have a function of x. So we'll use u dot v rule. So this is n x to the power n minus 1 phi of y by x plus x to the power n phi dash y by x, and again this is a function of x. So this will be dot minus y by x square. This is like this. So here we need x del u by del x. So let us multiply it by x and let us understand what we get. So this is n x to the power n phi of y by x plus here, let's see. So here what we see is here x square x to the power n. So by this, so this will be, and this is negative, so we get minus. So this is x to the power n plus 1 from this minus 2, and this y phi dash y by x. So this will be n minus 1 eventually. Similarly, we can find y del u by del y, which is x to the power n minus 1 y phi dash y by x. You can see it here. So we differentiate this with respect to y. So this is a constant for that, and we'll get this. So it is this. So now what we do is we need to add these two. So let us try to add. So now when we add both, we get del u by del x plus y del u by del y is equals to, so this is, let's see, so what we get is n x to the power n phi y by x minus x to the power n minus 1 y phi dash y by x plus x to the power n minus 1 y phi dash y by x. So what we get is this and this are same, so cancels itself, and we get n x to the power n phi by y by x, but this is u, so this is nu, and hence the theorem is proved. So this is Euler's theorem. It's very simple. So we now prove this, we can say as first order Euler's theorem. So we have another theorem which is second Euler's theorem. This comprises of second orders. So let us define it. Let u be a homogeneous function of x and y of degree n. Then x square del u by del x plus 2xy del 2u del x del y plus y square del 2u del y square is equals to, so here just what we have is n minus 1 u. All partial derivative exists. So this is everything about Euler's theorem. Thank you for watching this video. For any queries, join my group in the description, and here you can find the soft copy of the notes of the lecture and update of the next lecture. Do like and comment and share with your friends. Thank you.